Hello and welcome. This is Barrett from the C4 Cyber Club here at Cypress College. In this lab video today, we're going to cover the Ethical Hacking Lab series, Understanding SQL Commands and Injections. So we're going to be diving into databases, talking about SQL, which is Structured Query Language, so basically the language of databases. And the cool thing about this lab is we're actually going to hop into the Kali Linux machine, not going to start out attacking just yet, but you're actually going to work with some basic SQL commands, build a database, create a table, enter some values and things like that. So you can kind of get a feel for the back end of the actual database server. And then we'll move into SQL injection attacks and even using SQLMap to take a cookie from an administrative login through the web browser and see how we can actually dump the database, do some password cracking, things like that. So lots of things to cover in this lab, and it's a pretty diverse lab. All right, so first thing we need to do on the Kali machine is we need to start our database service. So we need to start MySQL. And the command for that is just service MySQL start. Whoops. There we go. Takes a couple seconds and we're good to go. Now we can run MySQL and we're going to say -u. We're going to give it the user that we wish to log in as, and that's going to be root. And now we are currently interacting with MariaDB, our database here. So this first part of the lab, we're just going to walk through some various commands. We could start off by saying show databases. And keep in mind, all these commands need to end with a semicolon. For example, if you forget that, it happens with me, it probably will maybe in this video. If you happen to forget it, you'll notice that it just takes you to this next line with this arrow. You can actually complete that command by just adding a semicolon. So you notice how it did in fact give us and showed the databases. If I had typed it correctly with the semicolon, you notice we get the same response. So I kind of wanted to throw that out there in the beginning because I think it's a very common mistake. But just know that you can still complete the command if you forget that semicolon. All right, so showing databases, we see that there's currently 3 databases here. Now let's say if we wanted to create a 4th one, we could say create database and we'll call it test. And ending with semicolon. Okay, query okay, 1 row affected. So now if we show databases again, we notice that that new database has been created. Now, if we want to interface with a particular database, we use the command use and then the database name. So use test. And you notice our prompt has changed to where we now, before we were at MariaDB none, now we are at MariaDB test. So we are using the test database. And if we show tables, well, it would make sense that it is empty. We have not added any tables yet. So let's create a new table. So step 13 here, create a new table within the test database for users and also populate it. So we're going to do 2 things essentially in this command. So we're going to create table users, and then we're going to give it 3 different values here. So we're going to say name can be a variable, and it could contain up to 30 characters. Account is another value that needs to be an integer. Balance is another value, and this needs to be a decimal. And also it could have up to 10 digits with comma 2 decimal places. So the syntax of this command is very important. So if you get an error, you need to be careful that, okay, we're creating table users, parentheses, name can be a character of 30 length. And notice that the 30 is within parentheses. A comma must separate each of these values. So name, account, balance. Account must be an integer, comma. Balance must be a decimal. And then you notice in parentheses, again, we have, okay, it could be 10 digits, comma, 2 decimal places. Then we have to close out that parentheses, and then we're closing out the final parentheses that started here. And then finally, we close it out with a semicolon. So that is good. We get query OK. And now if we show tables, here is our users table that we created up here. Now we have the fields here that we created. Now we also need to add data into those. So you see this command here, insert into the users table the following values. And we will go in order of name, account, and then balance. So John, because this is a string variable, it needs to be in single quotes here. And then we separate that with a comma. Now we're moving on to the account, which needs to be an integer. So that is 1, 2, 3, comma, we're moving over to balance. And this is going to be 10, which is 10.00. Remember that we can have up to 2 decimal places here. Okay, we close that out with a right parentheses and semicolon. Okay, query OK. Now this is an important command, and this is essentially what happens a lot when you're doing SQL injection and you're able to view all of the data that's in a table. You're essentially sending a command select star from users or select asterisk from users. But in this case, you know, this is a legitimate command. We want to view all the data that is in the users table. So currently we only have what we just input up here. Okay, and let's add one more row. So insert into users values. And this will be for Joe, 456 for the account integer, and 20.00 for the balance. Whoops, forgot the closing parentheses. There we go. And then select asterisk from users. Now we have both listed there. And you can use, if you're used to Linux by now, you can use the up arrow to also pull up history. So I could have done that to rerun that select asterisk from users command. All right, so let's add another table. So create table, give it the table name. So this is going to be called personal. And then we're going to add some different values, but you will also notice that some of these values will be similar to what we created in the users table. So we'll say name also has a character limit of 30. So the address, this will also have a character length of 30. City, whoops, character length of 20. And telephone, big integer. Okay, close that out, query OK. Now if we show tables, we now have 2 tables, personal and users. So let's go ahead and add data to the personal. So insert into personal values. Okay, we'll say John again. Whoops, sorry, closing out too early. 1313 Mockingbird Lane. So remember, these are for the characters. So these need to be in the single quotes. The city, Mockingbird Heights. And then finally, phone number 310-555-2368. And the parentheses that we started all the way here, and then close out with semicolon. Okay, query okay. And now let's add one more row. So insert into personal values, and this will be for Joe, he lives at Cemetery Lane. Okay, and phone number. Feel free to enter in whatever you like. These necessarily don't have to be exactly as the lab, but the syntax of the command definitely needs to be correct. All right, so now let's select asterisk from personal this time, the personal table. Okay, and there you go. So this time we have 4 different value fields rather than when we said, if we look at the users table, this is what we have there. Okay, so now moving on to the second part of the lab, we will query information from both of these tables. So we can select name and balance from users. So we're looking at this table here. We're selecting the name, but and also only the balance. So it will not return accounts. You can see that there. And we could do something similar with the personal table that's up here. We could say select name and telephone from personal. Okay. So we have that. Now, the cool thing is we can actually retrieve data across both tables at once. So we know that these 2 tables exist. We also know that the names match up. So you're going to see where we'll also be able to join those. So there's a join command in here as well. So let's go ahead and type this out and we can see how this works. So select users.name. So that's basically saying select from the users table the name field. Also users.balance. And then we're moving over to the personal table, personal.telephone from users. And we're going to join that with personal table, right? Where users.name equals personal.name. So whenever it finds a match between the 2 different tables, it will join those. And like I said in the beginning, I forgot the semicolon. So I'm going to enter it there. And there we go. So it pulled name and balance from the users table and also telephone from the personal table. And technically it also pulled name from the personal table too, but it joined those together. So it only showed us the one column there. And now finally, let's go ahead and do some deletion. So we can delete very specifically a row of data. So delete from personal table, right, where name equals Joe. And if we select asterisk from personal, let's take a look. And now we see only John is listed there. And now, what if we want to delete that entire table? So drop is the command for that. So we can drop an entire table, and the command here is just drop table personal, semicolon. And now if we show tables, you notice that the personal table is completely removed now. And what if we want to drop an entire database? We can drop database test, semicolon. Now you notice that the prompt, it forced us back to MariaDB none, where originally we were using test, but because we just deleted it, we are back into the main area here. So, and all of that work we just did has been removed. But going through this, getting your first hands-on experience on the server side should hopefully help you realize kind of what you're doing in the next part of the lab when we actually do SQL injection and we're attempting to attack these databases from the client side and dump database information from tables, learn schema information, learn all the different tables that are within a database, all through potentially a web browser, right? Or as we'll see at the end of the lab, we're going to use SQLMap as well, and we could find a lot of information through a tool like that. So let's go ahead and load up our web browser. And for this, we will, remember, we're going to be using the OWASP BWA website, which is essentially a purposefully vulnerable website that we can practice these hacks with. So we'll visit 192.168.68.12, and we will move to the DVWA. Okay. The login is admin. If you had just recently done and watched the lab on web pen testing, remember we actually brute forced this login using Burp Suite. So you should definitely remember that by now. And we have a section here set up for SQL injection. So we'll go ahead and click here. And this is where we can test out some of these injection commands, right? So, and remember the number one way to prevent SQL injection is good input validation on the web app coding level. So this is going to be an example of very poor input validation. It's allowing for some of these characters that, like the the single quote, allowing these kind of Boolean values of where 1 = 1 is going to translate into true. If you have a web app that allows for these things, this is where you're going to see how quickly sensitive data can be dumped. So let's go ahead and try that out. We'll do 1 = 1. And essentially what this is doing is, you notice in the lab, it says a query was sent to the database and it executed the following command. So think back when we were actually on server side interfacing with the database. It's basically the same thing as saying select first name, comma, surname from whatever table where user ID = 1. But what it's translating this into a true statement. So it's just going to send back whatever is in that user ID. We could actually do the same for 2 = 2. You'll notice it's not in the lab here, but you could play around with this as well. You could see that it's giving us the different user ID values for these numbers, but it's also recognizing this as true, which is why it's returning these values. Now, moving on, this is a very typical SQL injection command. This is one you'll see referenced a lot. So it's going to display all records that are false or empty and all records that are true. So let's do, so in this scenario, we were just focusing on one user ID, but now you're going to see we're going to return back a lot more. Whoops, can't see. There we go. All right. So now we were able to actually dump multiple. So we have 6 different first and last names here. So nothing extremely juicy yet. We don't have any passwords or anything, but let's keep moving on. Here we can potentially locate the database name. So let's tweak this command a little bit. Okay, so we still have the first and last name of the different users. And then at the very end here, you notice that, okay, now we do know the database name. It is DVWA. And we could also attempt to get the version number of this. So we use this null command here to kind of serve as a place value, because we need to search for first and last name. But then you're going to notice that in the last name or surname field, I should say, this is where it actually spits back, excuse me, the version number of the database. Okay, there we go. Similar as above, but now you notice that, okay, we have a version of Ubuntu that this server is running on. And let's see if we can get information. Remember I was telling before, we could potentially dump the information schema, figure out what kind of tables are on this database. Okay, so let's look for the table name from the information schema .tables. And here we go. We get the users again, but here we notice that we now have all this detailed information about all the various tables. So, this could definitely be used if you're really wanting to focus on a particular area. Maybe you need statistics for whatever this database offers, right? So now database name, and you could craft your query language based on this information. And now finally, let's see if we could dump these passwords. And of course, they won't be particularly passwords, but they'll be hashes, which would send you one step closer, because relatively easy to crack those, which we're going to see in the last part of the lab. And we're actually going to kind of automate that process. So here we're going to select the password from users. And now we notice here we have the hashes for each of the users. Okay, and these are likely going to be MD5. So we could crack these manually, individually. But yes, moving on to the last part of the lab, we're going to take a look at SQLMap. So this is a command line tool. Right now, we've kind of been going the more manual routes. You're kind of getting a first glimpse into like the life of a bug bounty hunter, where you're kind of going through a website, and if there's any type of form submissions like this, likely it's interacting with a database. And this is the type of place where you could try these kind of SQL injections. But now we are going to try something a little bit different, and it's going to require obtaining cookie and session ID information about this particular user, the admin. Okay. So let's go ahead and log out first. Okay, so we're back to the login screen. And we're going to use what are called web developer tools. So this also is something you'll become pretty used to if you get into bug bounty work. But up in the right corner here in the browser, you'll go to open the menu, and we'll come down to Web Developer and then select Network. Okay, so we have a split screen here, and we are going to log in, but as we log in, we're going to see some information pop up down here. So admin. This kind of assuming that we got the credentials for this account, and we're able to capture this cookie as well. Now, we want to look at the post request here. So we see the method column. We have a bunch of gets, but we want the post. Remember, the post is when you are actually sending to the server. So that is when the moment when we clicked the login button, and that actually sent the request to the server. And in here, we are looking for this cookie. Okay, so I scroll down a little bit there. You're looking for cookie. It'll say security equals low, PHP session ID, and we want to select all of this. So you could click and drag, but honestly, it's easier. And the lab also points it out. You can click here, press Control A. So that's going to highlight everything, and then Control C to copy to your clipboard. You could also right click. Oh, no, you can't right click. Never mind. So once again here, yeah, we find the cookie, Control A, and then Control C when it's all highlighted. So that's in our clipboard currently. So now we want to go back to terminal. You might still be in MariaDB. If you are, you could type exit. You could also create an open a new terminal window, but I just exited out there. I'm going to press Control L to clear the screen. And let me go ahead and minimize the web browser just to make it less distracting. All right, so let's check out SQLMap. Remember, you could always get help on a new tool, get SQLMap-H, and I encourage you to go through all the different options, and it shows you all the different techniques that you can use with this tool. We're largely going to be looking at adding a -u to target a specific URL. The lab gives us a very specific location to target. And then we're also going to add our cookie. And then finally, we're going to use the --dump command to attempt to dump the entire database. Okay, so let's go ahead and craft this command. And you notice that the lab does a really good job of breaking down these different components. So I definitely encourage you to read those. And then on the next page here, you actually get the full command here. Right, so we type SQLMap, because that is a tool that we're using. We're giving it a URL, so -u. And let's go ahead and type in that very specific URL that's in the lab. So be careful, because it is needs to be exactly correct here. And also, I would recommend not copying and pasting that, because remember, you have the cookie that we copied from the web browser still in your clipboard. So if you copied something else at this point, it would overwrite it. Okay, 1 and submit equals submit. Okay, double quotes ended. So that is the URL. And then we're going to say, okay, we want to add a cookie. So this is a double dash cookie equals quotes. Now this is where you have to paste. And I actually like to right click and do paste clipboard in NETLAB. It's a bit easier. Otherwise you can press Control Shift V. But you notice here, this is that entire cookie that we copied from the web developer tools. And we have to close that out with a double quote. And then finally, we say --dump. We want to dump this database and we're sending it this cookie, which is giving it the permissions of the admin, right? So press enter and off we go. And also something I forgot to point out, when you're crafting that, make sure that you don't copy this cookie up here. This is purely for example purposes. You just definitely want to make sure that you paste your specific cookie in that spot. So as you notice in the lab, and as SQLMap runs through, we're going to be prompted several times. So it needs some interaction from you as well. So looks like the backend DBMS database management service is MySQL. Do you want to skip testing payloads specific for other databases? So we could say yes. Once it's determined, we don't need to test for other database systems. Do you want to include all tests for MySQL extending provided level 1 and risk 1 values? We'll go ahead and say the lab recommends yes. I think when I did this the first time, I just said yes to everything. Do you want to keep testing the others? We'll say no. Maybe that will just move things by a little bit faster. Do you want to store hashes to a temporary file for eventual further processing? I'm gonna say yes, because yeah, we're gonna dump some hashes and we're gonna do some dictionary-based attacks. Yes. So do you want to crack them via a dictionary-based attack? We're gonna say yes. And so remember, if you've never worked with password hashes before, MD5 and or SHA-1 or SHA in general, it could be SHA-512. These hashing algorithms, they can't be decrypted. So all we can do is potentially match the hashes. So what that's going to do, it's going to scan through a word list and attempt to match hashes. And based on the match, that's how we can determine what the password is. Or actually, no, I'm sorry. It's asking us a question. What dictionary do you want to use? We're going to say, we're just going to press enter for the default. So it's this dictionary word list that's located in the user folder, share folder, SQLMap folder, data, text, and it's called wordlist.tx. Okay, do you want to use common password suffixes? We will say, okay, so that makes it kind of slow. So let's press enter to skip that. And here we go. And yeah, very fast. So cracked password for Charlie, ABC123. Let me scroll back up there. You could see that, remember, these are the hashes. I should still have it open. Oh wait, no, I don't, because we logged out. But you remember in that last part of our SQL injection part, we dumped these hashes, and we saw those in the website. But here we are able to just interact and dump the entire database through SQLMap, pull the hashes, reference it against a word list, and find the matches. And then down here, we see the passwords here. So admin, Gordon B, ABC123, Leet is Charlie, Pablo's let me in, Smithy is password, and user is just user. So pretty easy passwords. When you're facing these types of attacks, long, complex passwords are obviously recommended. It will take much longer to crack this way. And potentially, if it's a very unique, it's going to be really hard to do anything like a dictionary-based attack that's looking for actual words, right? And then, of course, another level of defense there would be to enable multi-factor authentication, so that even if something if somebody gets your password, well, there's still an extra layer of defense there. So with that, yeah, that ends the lab. We covered a lot in this lab. So we looked at just basic SQL commands. Remember, we hopped into Kali Linux. We started this MySQL service. We created a database. We created users' personal tables. We added values to those tables. We deleted them. We queried them. And then we moved into the actual ethical hacking part of the lab, where we interfaced with the web server, sent SQL injection commands, and then finally we used the web developer tools. We grabbed the cookie session from the admin user, dumped that into SQLMap, and speaking of dumping, we then use SQLMap to dump the entire database, get the hashes, and then crack them. So hope you enjoyed. This was Understanding SQL Commands and Injections for the Ethical Hacking Lab series. See you in the next one.